Number 24 is on amino acids, something you learned in the interim between exam 3 and the fun. Now, this question is basically a question that you write on your note card for the rules I'm going to give you. This question is, here is a structure of an amino acid. We give you pKa's associated with their individual functional groups, and we're telling you we put it in a pH. And that pH, according to this question, is just neutral, so pH of 7. Okay, now the rule is, if your pKa for that individual functional group is less than the pH, you will be in your deprotonated form. And I'll talk about what these look like in a second. And the other rule is if you have your pKa being greater than your pH, you will be protonated. You will be in your protonated form. Okay? Now, what do these deprotonated and protonated forms look like? Well, there are a couple things you can deal with and how they would look. Let's start with carboxylic acid. Carboxylic acid is going to be in every amino acid you ever deal with. And its protonated form is just this, where you have carbonyl and OH. So we'll do pro and depro. The deprotonated form of carboxylic acid would look like this. The carboxylate, where instead of OH, it's O-. And the protonated forms of OHs, where it's just an OH coming off of the amino acid, would be OH in the protonated form and O- in the deprotonated form. Sometimes you'll see sulfur groups, SHs. SH is like OH. It's protonated like this and deprotonated like this, S-. Okay? And then the other group you'll tend to see is the amino acid group, the amino group. And that in its protonated form looks like this, NH3 positive, and in its deprotonated form it is neutral as NH2. So this is a handy little chart coupled with this rule set that you can put on your card to help you get through these problems, because once you have this chart, there's not much they can throw at you. So now let's talk about the question they gave us. They gave us the structure of L-cysteine, and we need to figure out what does it look like in a pH of 7. So we are given a pKa of 1.7 for the alpha carboxylic acid group. Well, the alpha carboxylic acid group is, well, the carboxylic acid. And we're told that the pKa is 1.7 associated with that OH. So we go to our chart, we see that the pKa 1.7 is less than the pH of 7. And that means it should be in its deprotonated form. So I need to make sure that that OH is an O-. Now let's look at the next thing they tell us. The alpha amino group is 10.8 for its pKa. 10.8, that pKa is greater than the pH of 7, so that should be in its protonated form. The protonated amino group form is NH3 positive, so add a hydrogen to this and make that nitrogen positive. Finally, we are told the side chain has a pKa of 8.3. The side chain is this SH group over here. And we see that the pKa is again greater than the pH. So it should be protonated, meaning this should just remain as SH, the protonated form. So this would be your final structure, where you have the side chain being SH, the amino group being NH3 positive, and the carboxylic acid group being O-.